Today, I will be presenting to you my research paper on sustainability of electric vehicle production. And before we dive in, I need to mention that the automobile sector needs urgent action to address the climate crisis, as one of the key steps towards curbing global warming is phasing out fossil fuels and switching to more sustainable sources of energy. Whilst the market for electric vehicles is widely embraced, the impact on communities where the production materials are mined, which are mainly Argentina, Chile, and Bolivia, is being felt. These three countries are also referred to as the lithium triangle because of their importance in the extraction of lithium, as they account for over 75% of the world's supply. CO2 emissions have increased rapidly over the past 20 years, with nearly a quarter of global carbon dioxide emissions in 2019 coming from the transport sector, 70% of which were coming from road transport alone. Roughly 95% of the electricity consumed for transport came from burning diesel and gasoline in 2019, which shows the importance of automobiles to define whether we will be able to comply with the objectives of Europe's Paris Climate Agreement or not. These emissions are making many governments adopt new laws and policies, such as emission regulations, fuel economy standards, zero-emission mandates, and more, to discourage the usage of petrol and diesel cars and promote electric vehicles over the coming years. As a result of this, the number of global EVs went from only 17,000 units in 2010 to 7.2 million in 2019. Having experienced this growth from 2010 to 2019, there is an estimate of 26 million units by 2030 and 54 million units by 2040. We tend to perceive electric vehicles as the best solution to reduce emissions from the road transport sector, as they run on batteries instead of oil, cutting out exhaust emissions completely. But is swapping fossil combustion engines in favor of electric vehicles the right choice? Are electric vehicles the future? And most importantly, are they as green as they are pictured? The answer to this is that electric cars are not the future because of the production process of batteries, which comes at an unacceptably high social and environmental cost, which is why we need to look for alternatives. The supply chain and the life cycle of electric car batteries starts with the production of said lithium-ion batteries, which are based off extracting raw materials from poor countries and exploiting the involved communities in the process, mostly coming from the lithium triangle as it was mentioned before. After that, we have the usage of the EV itself, which is what we are mostly presented, as it is the sustainable and green part of the life cycle. Next, after about 2 or 3 years, the batteries reach its end and owners need to find a replacement for their old batteries. But what happens to the old ones? It is now more important than ever to find a way to repurpose, recycle, and reuse lithium-ion batteries, but unfortunately, as of today, we do not have an efficient and optimized way to do so. As the demand for electric vehicles increases, so does the need for raw materials used to produce the batteries we find in these cars, causing the value to double between 2016 and 2018. And while this market continues to grow, so will the price of the materials, making the production cost even higher. Although the countries are rich in natural resources, they end up being very poor nations due to the foreign exploitation. An example for this are multiple companies from other parts of the world, such as Germany, who mine the resources in the lithium triangle and export them to their countries, while heavily underpaying their workers and giving them poor working conditions. Furthermore, there have been numerous reports about heavy pollution, exposure to toxins, abuses, dangerous mining conditions, and child labor, to mention a few, which shows the gravity of the situation they find themselves in. Simultaneously, as an enormous number of batteries will reach the end of their lifespan, battery manufacturers still do not have an optimized plan for recycling batteries, since there are many differences in the design that make it hard to disassemble and separate the parts. This lack of an optimized plan results in high recycling costs, big volumes of batteries that cannot be reused or recycled, and low collection rates. One of the alternatives to EVs are hydrogen cars, which generally have a longer driving range and take less time to charge, but their negative aspects are that their infrastructure is not as developed as the one from EVs because of a lack of investment, which makes them less accessible, undesirable, and impractical. On top of that, they are also considerably harder and more expensive to obtain hydrogen than normal lithium-ion batteries. Car sharing is another very appealing alternative, as it does not change the car industry tremendously, but it has the potential to reduce CO2 emissions up to 38%. Public transport is the last feasible alternative, which would also account for a 30% reduction of the total carbon dioxide emissions released, making a massive difference if a large number were to use this instead of cars as their means of transportation. In conclusion, electric vehicles are a massive step in the right direction as they set a good standard of how we need to improve sustainability in comparison to today's mobility with combustion engine cars. But it also shows that there is a long way to go until we reach an optimal way of transportation that is emission-free and climate neutral or even positive. Thank you for listening.